So if you've heard me talk before, you've probably noticed that I talk about policy as code a lot. But what is policy as code? So if you have an organization, you have a number of requirements that come from things like contracts, regulations, internal expectations, whatever the rules of the road are for your organization, those can be distilled into human, readable, and understandable policies, right? The way that your organization is governed is by typically writing policy documents and then enforcing those policies on humans and systems. And the problem is that there's a giant chasm between writing a document and following those requirements when you're writing code. So you can see here we have a diagram showing a GRC analyst using a policy administration point like Word and writing a document, and then what do you want to do from there? Well, what you'd like to do is take that Word document and automatically put it in place between users or systems accessing resources. So we have this idea of a policy enforcement point, which gets information from a policy decision point, which is also augmented by machine readable policies. So the key thing here is that you have a Word document or Markdown file or a wiki, maybe even a PDF, and you want to get that to something that can actually enforce roles on users as they are accessing resources. So how can we actually do that? So in the Zenable platform, the way you would do that is go to that policy administration point, upload a file. Here we've uploaded a pair of Markdown files that have some requirements in it. You do an upload, and that creates a graph, right? So we have a patent pending graph database and policy as code system that is generated from those documents. You can see it's quite complicated. But then if we dig into it a little bit further, we can see what are all the controls that were described in that document. And if we just cherry pick one of them, like algorithms here, we can automatically create policy as code from the nodes in the graph, which came from the documents. So when you're enforcing policy as code, there's a number of different lifecycle stages where you might want to enforce that. Let's say we want to do that at deploy time, and we're going to do it with a tool called Chef Inspec. We have automatically created policy as code in the inspec language that enforces that you're using the correct algorithms, like not using RC4 or triple DES or MD5, and maybe allowing the use of TLS 1.2 or TLS 1.3. Now, we do all of this automatically, and we support a number of different integration points, and we're adding a bunch of them as well. You could also do this with Rego. If you are deploying to a Kubernetes cluster, maybe you're using the OPA Gatekeeper project, or maybe you're using Kyverno, and you could see we've got a Kyverno policy here. Or maybe you just want to use the built-in Kubernetes validating admission policies. We've got those built for you as well. But maybe the right place for you to enforce this control is not on deployment. Maybe it's when it's actually running. And so let's go over and go to AWS, and we'll just make a service control policy that denies certain algorithms from being used. That's one way you could do it. We could also do this at the source code level. So maybe you're using a tool like SemGrep. It's a great tool for enforcing requirements policies on software. And so we can see here, we've got all these weak algorithms, MD5, SHA-1, in different languages. And so we're supporting out of the box, Python, Java, JavaScript, TypeScript, Rust, Go, all kinds of different languages. And we've generated this automatically from the document that you brought in. All that you had to say is that here are the algorithms that we don't allow, and here's are the ones that we prefer to use, and then automatically make a whole bunch of different policy as code that automatically aligns with those requirements. And it does it at different points in the life cycle, so you can choose what the right point in time for you to impose that requirement is.